Hello, scientists. Thanks for tuning in. This video is about the various types of measurements that we make in science. We'll start with length. Length is the distance from one point to another. The way that we measure length is by using tools like rulers, meter sticks, and tape measures. The base SI unit for length is the meter. We say that it is the base unit because all of the other units are based off of or come from that one. The other common units of length are millimeter, centimeter, and kilometer. Next is mass. Mass is the amount of matter in an object. Matter is the stuff that everything is made of. Everything is made of atoms and molecules, which are the smallest pieces of matter that exist. We call these particles. The more particles something is made of, the heavier it will be and the more mass it will have. Something to jog your memory is also the states of matter. We know all about solids, liquids, and gases, which describe the movement of atoms and molecules in each state. All matter has mass. To measure mass, you use what is called a triple beam balance. You can also use an electronic balance or scale, which is usually more precise and easier to use. The base SI unit for mass is the kilogram. The other common units of mass are grams and milligrams. Next is volume. Volume is the amount of space taken up by an object or a substance. If an object takes up space, it has volume. Volume is the measurement of exactly how much space something takes up. There are a couple different ways that we can measure volume depending on if the object or substance is a liquid, a solid, or a gas. The most commonly used tool for measuring the volume of a liquid in science is the beaker. They come in various shapes and sizes, but they are all beakers. They have lines on them with numbers and units. They are best for measuring larger amounts of liquid and for when you don't need to be very exact. For smaller amounts of liquid, or when you need your measurement to be super precise and exact, you would use a graduated cylinder. It's like a much smaller and skinnier beaker, and it has more lines on it, so you can get a more precise measurement of what the volume really is. The base unit for liquid volume is the liter. This bottle of pop right here that you might purchase for a party is 2 liters. In science, we are more commonly dealing with smaller amounts of liquid though, so millimeters is the unit used most often. What about measuring the volume of a solid? It depends on the shape of the solid. If we have a box of some kind, all we need to do is multiply the length by the width by the height. In order to measure the length, width, and height, you would use a ruler, a meter stick, or measuring tape. Let's use this box as an example. We'll assume that each line represents a centimeter, or that each of those little squares is 1 centimeter on each side. So this box would be 6 centimeters by 3 centimeters by 6 centimeters. If I multiply those numbers all together, I get 108. But the units are not just centimeters. We can't say that the volume of this box is 108 centimeters because centimeters is used for length. We're measuring volume, how much total space it takes up, not a length. The volume of this box is not a line. The appropriate unit for this volume is the cubic centimeter, or centimeter cubed, or centimeter to the third power. In our calculation, we are doing centimeters times centimeters times centimeters. So our final unit is centimeter to the third power. When it comes to other regular solids like spheres, cylinders, cones, and pyramids, the volume of those can be found with other formulas. But what if you wanted to measure the volume of something that has a weird shape, like a rock or an action figure? Then you would use a method called water displacement, which means displacing or moving water. First, you fill a graduated cylinder with water, and you measure how much is in there. In this picture, it looks like the volume of water is about 150 milliliters. Then you would put the rock or other irregularly shaped object into the graduated cylinder with the water. The volume of both the water and the rock together is 180 milliliters. Then all you have to do is find the difference between them by subtracting. 180 milliliters minus 150 milliliters is equal to 30 milliliters. That must mean that the volume of just the rock is 30 milliliters because the water level went up by 30 milliliters to 180 milliliters when the rock was added to the 150 milliliters of water. Density is another important measurement that is related to mass and volume. Density is the measure of how much mass is contained in a given volume. This means we're trying to figure out how much stuff is in a certain amount of space. We can calculate density by taking the mass of an object and dividing it by its volume. Let's put density into perspective. Here we have two different substances. You can see that both are taking up the same amount of space, meaning they have the same volume, but the one on the right has a lot more particles inside of it. Which one is going to have more mass? Definitely the one on the right. It has more particles inside that space, so it's going to have much more mass. This means that the substance on the right is much more dense because it has more particles packed into that small space. The one on the left is not very dense because the particles are pretty spread out and there's not as many of them. Let's think about it another way. Here we have a cork. Maybe you've held a piece of cork before, but if you haven't, it is very, very light, meaning it is not heavy at all. And here we have a metal cube. Metal is often very heavy. So let's imagine that this metal cube feels very heavy. Which substance do you think would be more dense, the cork or the metal? The metal would definitely be more dense. There are more particles packed together in that metal, and we know this because it feels so heavy. We could figure out exactly how dense it is by measuring the mass and then dividing it by the volume of the cube. Next is temperature, and I'm sure you know that we use temperature to describe how hot or cold something is. The formal definition is the measure of relative hotness. We measure the temperature of objects or substances by using thermometers. You might use this one and hang it outside your window to see the temperature outside. Or you might use this one, which is a digital thermometer, under your tongue if you think you're sick. Now, you're probably used to measuring temperature in Fahrenheit, or perhaps you've used Celsius before too. The base unit for temperature is Kelvin, but we also use Celsius in science too. Lastly, we have time. We all know what time is, but the formal definition is the measurable period during which an action, process, or condition exists. The tools you can use to measure time are different types of clocks or a stopwatch. The base SI unit for time is the second. We can also describe time easily in minutes, hours, days, weeks, months, or years.